Suppose that we learned about creating domains in SQL. You remember what was the lecture? We were able to customize and create domains, right? Domains, what was the domain? What is a domain? Domain was a data type you define and you can use it in the create table and also in other types of create views or other types of the queries, the stored procedures that you are writing. Okay, so here in the SQL Server, we don't call them domains. We call it data types, right? If you open the programmability directory of the AdventureWorks, every database, you can see some parts here. You can see data types under the types directory of the SQL Server. Okay, so there are two types of data types you can define. One is table type, and the other one is scholar types or non-table types. What is the scholar type? What is the type? What is the non-table type? Here, for example, you see some of the examples of them in our database. The domain we defined. Excuse me, this should be. I think that it came here a little bit closer. Anyway, sorry, I forgot to record it. So today, as I mentioned, some of your friends are coming, so I will repeat it. Today, we will talk about a little bit about domains and data types and functions in SQL Server, and then we will continue our discussion about algorithms. So, as I mentioned a few minutes ago, in order to define a new domain in SQL Server, you need to define a data type, user-defined data types. So the concept of the data type is exactly what we were talking when we were talking about domains. So you can define user-defined data types, which is exactly a Scholar data type that you can use, or you can put limits on this. There are some difficulties over here, but I'm not gonna get into those difficulties, which is binding default values and binding rules to the data types. And we are not talking about rules in this course. Probably if you have another advanced database course, you can talk about creating rules in the databases, but here we do not have time to discuss about rules and binding rules and binding default values. So here, for example, in the AdventureWorks database, you can see a few number of the data types defined in this database. I can use this tool to show you that this data types are defined here. For example, you can see account number over here, which is one of the data types used in the tables. So, sorry. Okay, if you open this data type, you can see that there are several properties for this. First of all, it specifies which schema you are defining this data type, then the type of the data type you are defining, which is, since it's not table, a single varchar, and the number of the length of the data types. You can also bind rules and values. I don't have any rules and values in this database, so I cannot bind anything. Suppose that you want to create a new user-defined data type. For example, I would like to define student signature as a new data type. So what I will do is basically so I need this student signature as a data type because from now on I will have some scripts that will grade you. Since I will need to add this domain in most all of the tables then I need to have, it's easier for me to define a student signature as a data type with a specific length and with specific features, and then after that I can use it. Here, for example, I want to use I want to define this student signature. First I will go and select the schema I want to add this data type. Here, for example, I will use human resources. And the name of the data type is, name of domain is student. And I will choose it as a chart of lengths. So do I have this student signature over here? Okay. Oh. Do you have any person whose length, whose name is longer than 50 characters? Do we have anyone? I'm not kidding, just seriously. If you don't, then we can choose the length of the student signature at most 50 characters, including the spaces, right? So then, okay, and you will see that this the student signature will be added over here. Now, if I go here, so I have to refresh this table. Oh. Okay, I need to, in order to make sure that you can use data types in the tables, you need to define them as in the DBO structure, the DBO schema. So the one that I created was, I'm not going to repeat the creation in order to make sure that if you use the DBO schema, you can define the data type and domain, and you can use it in the designing tables. So I'm not going to repeat these steps, but I forgot to define. If you do not want to use the domain inside of the table and just the store procedure is required, then any schema you can use to define the data type. What is the user-defined table types? What is the user-defined table types? Why is it used? My question is, do you need a multi-valued field or or attribute in the relational database? Do we need, in the design of the tables, do we need any multi-value or a set value?
We might need.
You would like me to make it? Why do you want? It's not good. In the first normal form, you remove it, right?
Yeah.
So
Normal,
then,
normal.
if the tables are normalized, then you don't need it.
Yeah.
So why do they put user-defined table types? Maybe we don't need it in the tables, but I told that the domains are used not only in the tables, but also in the store procedures, queries, and so on. So this type of the data can be either a return type of a function, or a parameter to a store procedure, or anything like this, okay? For example, here, it has two user-defined data types. Which one is? But the first one is a small table consisting of order quantity, product ID, and a special offer ID. The type of each of these attributes are specified in the definition of the user-defined table type, and also it shows that which one is used to have as an index, to be used as an index. So product ID will be used as an index. And so index here shows that this the index shows that this table could be again large, you know, and you may need index for this table. So it is basically treated as a simple table, but this table can be sent as a parameter to a store procedures. Let me open one store procedure. So I will talk about the store procedures after we talked about algorithms of query processing, because you need to know what kind of algorithm you are using, and then you need to know, then you can realize that how the store procedure can help you with some statistics and so on. For example, what's the sales order detail? So let me find one related. Suppose that we have this store procedure, okay? We'll talk about this later, but you see some parameters over here, okay? For this store procedure, for this, each store procedure is like a function, but compiled and stored in the database. You can have several queries concatenated to each other and executed, and the data between these queries can be easily transferred from one query to another, okay? So the store procedure is basically giving some procedural semantic to the declarative language you are using for querying, which is SQL. So basically in store procedure, you can define different steps and show how these steps can be executed. You can, like in the SQL queries, you rarely can use if statements, but in store procedures you can easily use if statements, check if some table has a value, results is not null or null based on some if statements. And also you can use cursors and do looping on the cursors. So here, for example, as we mentioned, this sales order details passed to this store procedure is a table. Here you can see the name of the data type here is used sales order detail type. So, and also it's read-only, means that the data cannot be changed, the parameters, and it's not passed by reference. And so the rest of it is some sort of queries and inserting values and inserting stuff to this. So this is one of the examples that you need user-defined data and user-defined table types. So, and defining user-defined table types has a very simple syntax. So basically, you define a type. This is create type is similar to what we learned, create domain or define domain in SQL, standard SQL. You put the name of the type, and then as the table, which is basically a specification of the columns of the table, and the rest is similar to creating table. So, and from now on, you can refer to this table, to a small table, as sales order, as this kind of data type. Okay, now before considering store procedures, which we'll do next week after we learn about algorithms, we need to know about functions. What are the functions? We learned about functions. What are the functions? What are the functions in procedural languages? In Java?
Chunk of code which is designed to do particular task.
No, I cannot hear it. What was the function?
It's a chunk of code which is designed to do particular task.
It's a chunk of code. It receives, first of all, some parameters. Function is in mathematics. What is the function in mathematics? A function is some relationship.
Get some parameters, use some output.
Yes, for each specific combination of the arguments, it has just one output. You know, it keeps a one-to-one relationship between many-to-one relationship between from the input domain to output, right? Here is the same thing. You know, we have the function. The function receives a few parameters, and in return, it may receive nothing as a parameter, okay? And it returns some value that we can use in different queries and store procedures. So functions are basically, we have two types of functions, basically, which is one is table value function. What is a table value function?
The output will be full of tables.
The name is very explanative. As Fanilda told, the output of this function is not just a single value. It will be a table, okay? So, and this table can be used in any place you need a table. For example, you can treat the table, you can put the table as some part of the join function, join relationship in the select queries. And scalar value functions are those functions returning just single value, okay? So here is a simple example of functions you can see in the Adventure Work database. For example, here, let me use this technology. Here, you see that this function has a single parameter, which is an integer, and so how we define the function? To define the function, as we saw in the slides, we need to use create function, and then we need to put the name of the function here, and then some parameters. And then after that, we specify the type of the output, okay? Here, the type of the output, since the type of the output is table, first we put a name to the type of the to the output. For example, here I put a name rich contact information as table. Okay. If we don't put a table over here, if I scratch this, this will be a scalar function. The result cannot be a table. So then I will receive an error because this part is redundant. But now this function is a table valued function. It means that this function returns a table. So I put a name over here for the name of the output, and I say that this is a table. And now after that I define now I define the list of the columns and attributes I have, and I would like to be included in this table. For example, the first column is person ID. The second column is first name, last name, job title, and this is business type, business entity type. So I put this columns over here. Now I start to define the function. So in the function, similar to stock procedure, you can have different steps, and each different step can have some different processings. So at the beginning, I will check if the person ID, if the parameter given to this function is not null, do the rest. So what are the rest? People, can you help me? The rest is some simple SQL queries that you have midterm next week, and you know what these queries are doing. Who wants to help me? You know how to write triggers, and in triggers you know if statements, right? So what is this part? What does it say? This part? And also different colors here. What is this part? This is the first part of the query, basically. What should I put the name? Functions. Hold on a few seconds. Okay, so this part says that, okay, if the result of this select is not empty, what is this select? What is it? It selects all the rows from the human resources employee, where the business entity ID is equal to the parameter passed to this function. Note that both the parameter and output type are marked with this @ sign, right? So first you check if it is correct, if this condition holds. What we are doing is basically we are doing the rest of the query. What is the rest of the query? This is an insert into where? Insert into, what is this? Red contact information. Where can I find this one? You don't want to. This is the return type, right? This is the return value. Okay, this return value is a table. So since it is a table, you can write queries on this table. One of the queries you can write is insert into. Okay, you can insert into this table here by this statement. The next statement can use update. The next statement. So this is exactly a simple query. So you are inserting in this table, the temporary table you created. Select person. You select these fields. You select this field, and finally you also add one type to this, which is a constant, which is the employee, which says that, okay, this guy is an employee. Okay, also confused with this new technology that I'm using. So we select this information from this employee table. We insert these values into the return type to this table, and then move on. So then first we check that if the person ID is inside of the employees, then we will add this information to this employee. If the person ID is among the information we have for the vendors, purchasing vendors, in the tables you can find purchasing vendors, right? Here. Okay. We have a purchasing vendor table over here. Okay. Now it's very difficult just moving to work. So if it is not null, and if you have someone with this business entity ID in the vendors table, then you also insert into return table some people this sequence of values with marking that the type of the person is vendor contact, or the contact type of the contact is vendor contact. And so again, this is an insert into query. There is another select exists. Again, similar thing happens if you again retrieve some people from this another table and add this to the result. And finally, you after finishing all of these if statements and all of the actions, you return. When you return, the table, this red contact information table which you created will be returned. Okay, this is one type of the functions that you can have in the SQL Server. So similar to this one, even simpler, we can define scalar value functions. For example, here, let's see, I want to have some functions and parameters. This is another example from the for the parameters that you have for the functions you have with different parameters, but the return value of the type of the function is not table. We don't see the keyboard table here. If it was table over here, then this should be the return type will be table value. Similar to the previous one, you have the name of the function, create function, keyboard is equal to keyboard, the name of the function, and open parentheses, the types of the input, and the return value, list of the arguments. So inside of this, you define two different local variables. One is dealer price, the other one is dealer discount. Okay, both of them from type money. Right, the data type money is a standard data type in the SQL Server. And then you have some calculation over here. For example, you put this dealer discount over here, and then you use this select query to compute some values, and then you finally return the value dealer price created here as a single value to the output. So this was the functions in the SQL Server. Is there any question? Is there any question?
How to run these functions?
How to run this? You can use these functions inside of the queries. For example, choose. Let me see what is this function. So this is returning the date time, okay? Now I will write it. It returns the value. Okay, or let me use another one. Get contact information. What's the parameter for this one? It was a person. What was the person ID? Hold on. Oh, it's business entity. Okay. So let me write another query using this table value function. Yeah, I can use two. Two is another. Returns a table, right? So, but in the from you have to give a value to the parameter for when the return type is the table, okay? So this is, for example, Rob Walters. Hold on, what's the name I should put here? What's the sorry. So let me write a. So suppose that we want to write a function called Phanidra. Okay. So what is the so Phanidra? Give me some example functions. Some function that you want. Because you asked the question.
Give any date, it will format the date and give the proper date.
What was that? Give us a simple question, you know. I have 5 minutes to write it. Vijay, you have any idea of some other function? Ladies in the back.
CPSC.
Monica, do you have any suggestion for a function?
So what is the question again?
It looks like people are not listening. So the question is that give me a simple function I want to write.
We can have. Sales we can have. Sales.
Sales of what? Sales on, let's see, what do we have in the sales?
Even a 9.
Sales person.
Answer that one. Answer that one.
Okay, so suppose that we need a function to keep the ID of the salesperson and get the number of the sales order he got. Okay, suppose that you need a function to give a salesperson ID, business ID of the salesperson, and return get back the number of the sales. How can I write this function? From the back row, I will start getting help. Vijay and teachers are laughing at each other. Okay, so from the back row. You don't have any suggestion? How can I write this? Any suggestion? Just a few minutes ago we saw the scholar. So hold on. What is the question? We are looking for a function. Let me write it over here. I see. I have a few minutes because I want to continue. Write a simple function to receive the business entity ID of the person, of a salesperson, and return the number of the sales order he or she has. Okay, this is the question. How can I change the font of this? Okay. So now, tell me, what should I do?
Input should be one value, return should be one value. It's a scalar function. It's a scalar function. Input should be one value.
Okay, so say the first hint by Fanindra is a scalar valued function. It's a scalar valued function. So, who has MySQL Server Studio? So who has MS SQL Studio Management open in front? Oh, everyone, every computer has MS SQL Server. No, it's not, you're not watching movies, right? Okay, so if you have SQL Server Studio Management open, you can go and just check one of the functions we had. For example, here we go and see create. So in order to write a function, the first part, the name. Second part, parameter. Okay? And the last part, the type of is, if it is a scalar value, just you need to specify the type you want to return. Okay, so now tell me how I should write it. New scalar value function. I put the name of the function. What is the parameter?
Business entity
Like
ID of salesperson.
this. What's the parameter?
Business entity ID of a salesperson.
You don't need to specifically put business. You can put any name, right? What's your name? What's your name? Yeah. Mofika, I put the name of the parameter Mofika. Is it correct explanation?
OFIC.
OFICA. Mofika has, what is the type? Integer, right? The business person ID was integer. Okay. Now, return type. Return type is, again, integer, right? Okay, so, hold on. I want to use the same template as this guy is using. So, that's the integer. Okay, so now what is next? What is next? The value, return value, which was integer. Sorry, man, I need to keep the microphone. So, what is next? Just take a look at this one. It declares one local variable and finally returns a local variable, okay? So here, what's your name? Yeah.
Shikha.
Shikha. S-H?
S-H-I-K.
S-H-I-K.
H.
H. And I put the local variable of Sheikha.
A.
This is, okay, as an integer, okay? This is your variable. So now, what I want to do is, okay, I want to return this one. Okay? So, who wants to write the query? Next Thursday you will have a midterm and you are looking for this Thursday. Went closer. You were about to be lucky that, yeah, for me. No, don't worry, I have the questions right now in my canvas. You know, everything is ready. So, given the query, in 1 minute we have to go back to the lectures. Come on, guys. How many tables do you need? What is the question? The question is, write a simple function to receive the business entity ID. Okay, distance learning people are watching you. Just give me the answer. Business entity ID of the salesperson and the number of the sales order she has. Get back to the tables. Where are the orders? In the sales order header. You have salesperson ID over here, okay? So what you need to do is, I need to put Shikha here equal to what? Right? Count of what? Okay, now from which table? This table. Where condition? To what? Says person ID to equal to what?
Business entity.
Hmm?
Business entity.
Mofika.
No, we have the salesperson ID over here. That person is the salesperson ID is here exactly at this business ID, entity ID. But this equality condition this is a simple select query returning the number of the salesperson ID is the one that I want to check from the table. The other part should be given from parameters. Who told parameters? And what is the parameter? Mofika is the parameter. Mofika, why are you silent over there? So, yes. Now this is the function I wrote. I'm saying it. Function SQL. Okay. Now, if I go here, what's the name of the function? Find it, right? Okay, first you execute this, and you execute it, it will be compiled. And then it will be added to the scalar value functions, okay? Now you see that Phanindra is here, both in the classroom and here in the scalar value functions. Now, Phanindra, I want to see how I can use your function. How can I use your function? Let me find one salesperson. For example, 287. 287 is a salesperson, right? Now, I want to see how many orders this guy got. How can I do that? Select what? Select what?
Function name.
No, you have Phanindra over here now. You wrote Phanindra, you have to use it, right? So, DB of Phanindra. What was the number? 284?
287.
287. 287. From where? Should I put from where here?
No.
Phanindra says no. Vijay says business entity. No, why? We don't need from. The function does everything. You just have a select. Select, give me this back. Okay? And the function computes it and it returns to you. So, is it clear for everyone, functions? Now you can write functions at home?
Yes.
Okay, so you will do practice at home. I suggest you to, if you have roommates in the same class, in this class, give him this competition at night. Start design a question, give him the question, and you should know the answer. And if he cannot solve it, then you get a point, and then in return you will get back a question. And if you cannot solve it, this is a good competition. It's a kind of Olympics of database, right? So if you have this kind of Olympics at home, then definitely you will get an A in this course, even more than A. So
More than A.
I mean, it was imaginary. Yeah, I know.
That's good. Imaginary.
I'm not sure if the Olympics happening also. But if the Olympics happens, maybe. Okay, so let's get back to the next lectures because we are far behind of our schedule. Sorry. Okay, so what was the last discussion we had? We had this. Did we talk about access path or not? So you know the access path from the previous lecture. What was the access path? The previous lecture when we were discussing about index structures that you are supposed to know and you will be expected to know on the Thursday's exam, right? What is the access path? The access path on these slides was the combination of the algorithm and the data structures will be used to retrieve the information from database, right? Is that correct or not? Yes. So here again, we use the same notation. The notion of the access path is the notion denoting the algorithm and data structure together to locate rows where we are satisfying the conditions. Okay. How many access paths do we learn? We learned how many access paths? We learned first file scan. What was the file scan? In order to find the specific row with a certain condition, you needed to go row by row from the beginning of the file to the end to find that row. Okay? What is the second access path we know? Monica was saying something.
Indexing.
Indexing, and one of the indexing was hashing, right? What was the hashing access path? In hashing, what you are doing, you have a hash function, right? What was the hash function? The hash function was the function given a value based on, for example, the string representing the name of a person. It returns you a unique number, a very big unique number. And from that big unique number, you choose some part of it, some part that makes sure that the number is still in the range of the values unique. So for the equality search hash access path, what we are doing, we learned about equality search hash access path. We use this hash. What did we do in the equality search access path for hashing?
What is equality search?
So you have a few attributes, okay? For example, name, last name. For example, we want to find the record of Bennett Matthew in the file, in the database. So what we are doing is, first of all, the hash function should receive as a parameter both of the attributes, okay? The hash function returns the records of all the Bennett will be helpful, but it will need another step of the search. But in order to make the search easier, we need to have our hash function based on both first name and the last name. So all of the attributes participating in the search and all of the attributes of the search key should be in the hash function. Hold on, I need to. So what we did was basically we gave the search key to the hash function. We got back a location or a hash value, and we know that that number is somehow locating the record of Mr. Bennett Matthew. Okay, so and then we go to the file and exactly retrieve that record. This was the hash function. What was the B plus series hash access path for equality search? Suppose that we have this B plus 3 based on the last name, and we are looking for Bennett Matthew. So we know that in the leaves of the B plus 3, records are sorted. Okay, or all of the records of people with the last name of Matthew are located close by or adjacent in the leaves. Okay, what we are doing is we give the Matthew to the B plus 3, find the first Matthew, and then we go and retrieve all of those records and see who is Bennett Matthew. Okay, so this is how you search. So unlike hash function, you don't need to have the whole, in order to have a robust search, you don't need to have the whole search key as a parameter of the search. A prefix of the search key can be indexed also, and if we have some part of the search key as an index, even that thing is also helpful in this case. What was the binary search? The requirement for binary search was we needed to have the relationship sorted based on the search key, and then when we get the search key value, what we are doing is we started running the binary search algorithm. What was the order of the binary search algorithm? Log of f of 2. So again, some more examples. Suppose that you have a B plus 3 whose search key is the sequence of A2, A1, A3, and A4. We have what do we have here? Multiple attribute search key, multiple attribute index, right? You studied very well. You responding. It looks like I have to change the number of the questions from the number of the indexes to number of the from the number of the SQL. I have to decrease and add some more indexing questions. So suppose that you have this type of this query. Do I have this technology or not? What is this? Suppose that you have this query. You are looking for all the records from the table where A1 is greater than 5, A2 is equal to 3, and A3 is equal to X. So how do you search it? How do you find all of the records matching this condition? This is B plus 3. Everything is sorted. What does it mean that everything is? First of all, the sequence of attributes is like that. Okay, so you know that in the leaves, records are sorted based on first A2, then A1, and A3, and then A4. Okay.
Just first we need A2, right?
So first we locate A2, which should be 3. Okay, now we should locate.
A1.
We find the first A1, which is greater than 5. Okay. And then we find A3 is equal to X. So after that, we know that all of the records may match this condition. Why? Because we know that these are all together. So we start to search. We start to scan all of the records. Okay? So when we start, we know that from the now on, A1 is greater than 5. So our concern is that A1. because we are searching after A1. Okay? So we start from this point, looking for each record. As soon as we find the record is not matching with A2 greater than 3 or A3 is not equal to X, then what we are doing is stopping the search. Why? Why?
If they are not matching, then automatically A2 will not be.
If it is greater than A2, if A2 is greater than 3, then we know that no longer A2 is equal to 3. So why are we wasting our time? Okay, so we stop at that point. If A2 is still equal to 3, but we find someone that is not, we find someone A3 is not X, it means that those people with A3 is equal to X is
Completed.
over. Now we are moving on and we are finished. Sorry. Now there is another query. So let's try to answer this one. A2 is equal to 3, A3 is greater than X. First we locate the first we locate the first entry with A2 equal to 3. Then we will scan until A2 is greater than 3. Until that time we all have to scan. Why? Why?
You should take A3 also.
Every record after this, until this condition held, maybe satisfying this condition, right? So because the second attribute is a range query, and it shows the minimum value. Okay, so after this point, every query may satisfy the condition, unless we get to a point that A2 is greater than 3. It means that we are done. We have to leave. So, what is the last example? A1 is greater than 5, A3 is equal to X. So what happens here?
Scan all.
Why?
It's the range for is greater than 5. It can be anything.
Because first of all, the prefix of the search key, because the search condition is not a prefix of index. No part of the search condition is a prefix of index. So we know that the leaves of the B plus trees sort based on first A2. So since we don't see any A2, it means that the rest of the values are randomly distributed on the leaves. So we cannot use the B plus 3. Okay. So how database chooses an access path? How DBMS uses this concept? First of all, when we use database, we want database to answer and respond our questions as fast as possible. So in order to decrease the number of the decrease the time of the query responding, we need to decrease the number of the pages we are transferring always. Okay? So we define a concept called selectivity. What is selectivity? I'm using this circle every time. I'm very happy with this tool. What is this selectivity? It's the number of the pages we are transferring. Okay? So if DBMS knows how many pages, or if the DBMS has some estimations about how many pages each of the access paths need to transfer, then it is going to use the access path that has the minimum number of page transfers, right? So it's not stupid, it's going to find the first, sorry. Okay, so if there are several access paths existing, then it uses the first and the shortest access path. So what is the first indicator for this access path? For example, you want to find all of the records that has, suppose, okay, let me give another example here, the blackboard. Suppose that you have a table of car and dealerships, car models. Okay. So, and you know that you have three types of the cars, like Ford Focus, Chevy Malibu, and Toyota Camry. You have these three types, and you have 100 at these dealerships. So, you have this query to specify the dealerships, numbers start with 5 and sells Malibu. So suppose that you have this table and you are, as a smart person, you want to find these records, these people. You know, you want to buy a Chevy Malibu, and you have this directory. How do you search? How do you search? Choosing which field is better for you? Suppose that you have 300 rows. If this field is sorted better, or this field, this attribute.
Dealerships.
What?
Dealerships.
Why?
We're starting with 5, then we're searching with.
Because your dealership, because the domain is larger, the condition is choosing less amount of records. Okay, so as you told, if you choose first the records that are starting with 5, the number of the records will be less than if you choose the records starting selling for Malibu. Okay, so you have first you search and you retrieve a few number of them, and then you consider the second condition on that. So this this is the way that you search for. So similar to this one, database is also doing the same thing. For example, here there is an example. Suppose that you have this table of transcripts which has different grades for each course. Okay, so you know that the domain of the course code is larger. You have a lot of courses. Okay, but the domain of the grade is smaller. You have a few number of types of grades. Okay, A, B, C, D, for example. So, so if you have a B plus tree based on the course code, and then the execution of this query will be easier because you go for the course code first, choose a smaller number of the records, and then consider which one is B plus B. So, drawing. Okay, I'll continue next week.